Good day again, everyone. So, today in this session, we're going to talk about Eplan1D. So, again, you can download this in your Moodle week 4 here in Eplan1E. You can download here. So, this the file and this is the chart. So, first things first, we're going to download them together. So basically, Eplan1E is just the same as running fix. Only this time we took into consideration the tide when we plot our running fix. So as per usual, you download this Eplan1E, print it, and read it carefully. Uh, After that, you secure the materials. This time we're going to use chart number 4, which is also found in the Moodle, chart number 9A, 9B, and you read the scenario, and we focus your attention here in the performance criteria. Again, all I want is this answer for this one and this one. So same as 1D, uh, the other task is already visible in the chart, so I'll just only need the two answers. So now we proceed with the scenario description. So at 13:30, the vessel is at the vicinity west part of Panay Island. On course 200 degrees through and 10 knots with the falling tide. The OW observe Posho Lighthouse. It bears 330 degrees relative, and after 30 minutes the same object was observed, and this time it bears 270 degrees relative. So focus your attention here, remember west part of Panay Island, and it says falling tide. We're going to discuss that later, but we proceed here first. So as always, you need to convert this into true, as I mentioned before. So 330 degrees plus 200, which is your course, equals 530, and minus 360 because it exceeds 360, so that is 170 true. So the same as the second one, and then we get 110 degrees true. So now we proceed with the chart, but before that, let me have a tour with here in the Moodle. So first, I like to say again that as always, you can always find the symbol in the chart here in this book. Uh, this is namely chart the Admiralty 5011, but this all the legends in the chart is can be found here. And it's still loading, but the legends in the chart can be found here, and the section which we're going to be concerned about is this one, the chart symbol. So when you click that, this will be the image. This can be found in the chart 5011, which the PDF file. So you remember this ebb tide. So as I said earlier, flood tide with flood tide is also, as I said earlier in Eplan E, falling tide is uh, synonymous to ebb tide, so that's here. So remember this description, this image, because we're going to be using that on the chart. So now this is so now we're going to open the chart. So now this is chart 9B. So as shown earlier, this is the falling tide, 1.4 knots, and in the description it says falling tide, so we're going to use this with 1.4 knots speed and going to south. So I would like to say that you need to pay attention to this latitude scale, because this is on a different scale, 55, 56, 57, 58, 50, 55. This will be 55, this will be 56, 57, 58, and 59. So just bear that in attention. And as for the moment, you can see there's no latitude scale. So as for the moment in the E-plan, you just only answer the latitude part. I will give further instruction, but if not, then as for the moment, because there's no latitude scale, longitude scale, you just only answer the latitude part. Okay, so now you know that we're going to use this one, not this one, because as in the book, this is falling tide. So going to this is the push hook point, as you remember. So in the E-plan, it is said that west part of push hook point, so our observation will always be in the west part, so in this area. So the first observation set as calculated is 170. So we're going to take a line 170. So again, I need to stress out that when you plot, you should always label this same as in Eplan1E uh, according to the international standard. So this is 170 approximately. So put here 170. So this is the first observation at 10:30. So now the ship is on course 200. So you're going to make a line of position 200. And it could be anywhere in this line. So 200 could be anywhere in this line. So in our case, we just put it here. And it says that at 10:30 and after 10:30 with a speed of 10 knots. So going back in E-plan, here 10:30, 10 knots, then after 30 minutes. So 30 minutes of 10 knots is 5 nautical miles. So 5 nautical miles. So again, in this exercise we don't have compass divider, so let's just assume that 5 nautical miles is here. Let's just assume. And this is your DR. So again, you should always plot the international annotation, DR, LOP, course, and all, but in this demonstration I will not be doing it. Okay, so after you plotted your DR, we will now next put the effect of the current. So this is the current 180, so you put 180, put it here in your DR, and with a speed 1.4 knots in half an hour should be 0.7 knots. So that's why in the latitude scale we plot 0.7, so 0.7 should be, this is 246, so 0.7 should be here, and you put it for, let's just assume that this is the DR with the effect of current, because after you put 180 you will measure 0.7 knots. So this is now DR with the effect of tide, this one. So let me zoom. There's two DR, the first one, and with the effect of the tidal stream after the speed, that's your second DR. So so after that, you plot the second observation, which was 110. This is the second observation. So again, bear in mind that this is only for demonstration purpose. The real drawing, I will not guarantee that the real drawing should look like this. But anyway, there's a supplement video for the real plotting in the actual chart. So this is the second observation, and after that you're going to use the first line, which is this one, which has a course of 170, and you just drag it here to the second DR, the one with the tidal effect, and then once it intersects, this will be your running fix. So this will be the final answer, which you're going to put in the final exercise here. So distance run after an hour should always same 10 knots. The other task can be accomplished when you put in the chart. So for now, you only need to put the latitude. For now you only need to put the latitude at 1400. So in summary, first you need to convert the relative degrees in Eplan1E to true. Then you look at the chart 500 for the meaning of falling tide, and after that you first put the first observation, which is this one, 170, and you put your course 200 at any line here, and after that you put the 5 knots here, which is 5 nautical miles, and you put your course, the course of the current here, which is 180, and with the effect of the current, which 0.7 knots, and you plot another one, another DR here, which is this one, and then the next one is you put the second line of observation, and then you just drag the first observation to the DR with the effect of current, and this will be your running fix, this one. So this is just again a demonstration purpose. The real exact drawing will be on the real chart, which is a supplement to this video. So basically that's all, and thank you.